Hey everyone, I'm going to show you how to do the calculations associated with question number 1 or prompt number 1. This is all about drawing a heating and cooling curve or heating or cooling curve. And the first prompt here is basically giving a scenario where 25 grams of water, so a liquid, at 22 degrees Celsius, our temperature there indicates that we're in the liquid phase, is heated to 110 degrees Celsius. Now, this table down here shows us the information that we need, that we will be using. But the first thing that you want to do is draw a heating curve. Okay, so our heating curve is going to look a little bit like this. We've got solid, which I'm going to label S, liquid, and gas. Now, what I also want to do here is I want to label these horizontal regions or these plateaus. Our temperature is on our y-axis. This is going to be at 0 degrees Celsius, and this is going to be at 100 degrees Celsius. So the transition from a liquid to a gas is at 100 degrees, from solid to a liquid is at 0 degrees Celsius. Now, what I need to do is I need to kind of track what's happening. And if I like to go ahead and draw a little line to indicate, basically I'm starting right around here, right where that dot is, and I'm ending up right around here. So my question is, how much heat is being added, or how much heat is required to get from there to there? And so I'm going from a liquid to a gas. What I'm doing is I'm going temperature-wise, I'm going from 22 degrees to 100 degrees to 110 degrees. So 22 degrees Celsius, 100 degrees Celsius, and 110 degrees Celsius. Now, that means that my temperature has to change from 22 to 100 and 100 to 110. Now I've got this transition, this region right here where I've drawn a little X. Where I've drawn a little X, that is where my vaporization is going to take into account. And that's where I'm going to be doing something called enthalpy stoichiometry. So I need to be taking into consideration that change there. And so what I'm going to do is a couple of different calculations. So the first calculation that I'm going to do is going to be a Q equals MC delta T calculation. And what I want to do here is I want to figure out how much energy or heat is involved in 25 grams of water being heated from 22 to 100 degrees Celsius. I say 100 because that's where my vaporization is going to take place. That's my boiling point. So I've got my mass. Then I need to account for my specific heat capacity, my C, which is heat capacity of water, which is 4.184 joules per gram degrees Celsius. And then my temperature change is 100 minus 22. Okay, so this is going to give me the Q value. If I plug in 25 times 4.184 times 100 minus 22, which is 78, I get Q is equal to 8158.8 joules. Okay, so 8,158.8 joules of energy are required for this. Now, what I need to do next is that enthalpy stoichiometry. So I'm not watching a temperature change, but instead I need to think about the delta H of vaporization. So to get something to transition from a liquid to a gas, how much energy is associated with that? And so this is where, or another place where I'm going to take into consideration the mass of my water, 25 grams. Now I'm going to go ahead and change color for this calculation. What I need to do is take 25 grams of H2O. And then I need to convert that into moles. Now the periodic table tells me that 18 grams of H2O is 1 mole of H2O. and my delta H of vaporization is 40.67 kilojoules per mole. So to convert, it's 40.67 kilojoules of energy to convert 1 mole of H2O. So I want to say 40.67 kJ is 1 mole of H2O. So what I'm going to do is now I'm going to say 25 times 40.67 divided by 18. And the answer here is 56.5 kilojoules. Okay, so I figured out the heat required to increase the temperature of water from 22 to 100 degrees Celsius. I've also figured out the energy associated with 25 grams of water converting from a liquid to a gas. And the last thing that I need to do is figure out, with another Q equals mc delta T equation or calculation, what is the amount of heat required to increase the temperature of 25 grams of water by 10 degrees Celsius. So let's see, this, I'm going to point an arrow there, and then this calculation is going to be pointing an arrow there. 25 times 1.84 joules per gram degree Celsius times, and that would be 110 minus 100. So that is going to be 25 times 1.84 times 10. That is 460. 1.84 times 10. Yep, 460 joules. Okay, so the heat to go from here to here is a combination of all these things. Now, it is very tempting to get those numbers, add them up, and move forward. But we have to realize that our units are different: joules, kilojoules, and joules. So what we need to do is convert from joules into kilojoules. So 8,158.8 is the same as 8 point, I'm going to call that 16 kilojoules. Then 460 joules, this is the same as 0.46 kilojoules. So now what I'll do is I'll say 8.16 plus 56.5 plus 0.46 equals 65.12 kilojoules. That's the total amount of energy required to go from 22 to 110 degrees Celsius. Keeping in mind that we had that variable of converting from a liquid to a gas. And that's where we had that enthalpy of vaporization that we had to account for. Now, we have to know this terminology, vaporization versus fusion. We have to know liquid to a gas is vaporization. I hope that was helpful. Have a good one.